exponentially with age. Okay, so you guys know that from your past experience, the slope of the tangent line is the derivative. Okay, and for a straight line, the tangent line is itself. So in this case, the line is horizontal, so its slope is 0. Right there. Okay? So any function that is a constant function, i.e. a horizontal line, its derivative is 0. Okay? So that's the constant rule. Is everybody okay on that? Right, next set of rules. This one we've spent 3 days doing this, okay? This is what you developed in the computer lab. Okay, the power rule. Okay, do I need to explain this one? Is everybody okay? So what you might want to know is, you might want to know this sort of pattern here, okay? It's kind of fairly obvious, but I'll just write it down. So for example, if it's a constant, it's 0. If it's x, it's 1. If it's x squared, it is 2x. If it is x cubed, nice, good job. And if it's x fourth, 4x cubed, okay? And so on. So that's kind of for this problem here, okay? For this problem here, okay, you're going to use the power rule. So you're going to take a half, move it down here, and then you're going to reduce the 1/2 by 1, which makes it this. Does everybody know how I ended up here then? Do I need to explain that? This is using the laws of exponents that I gave you yesterday, right? The 5 or 6 rules that I gave you yesterday. Is everybody okay on that? Does anybody want me to go over that? Chris? Go over that? Okay, do you have your rules from yesterday? Did the dog eat your paper? Okay, it's at home. The rule you're using is this one here. In other words, if you have a negative exponent, it goes downstairs. You are also using this other rule that I gave you. Okay, so in this example, P is 1, Q is 2, so then it becomes square root of x squared, square root of x. Okay, square root of x. All right, is everybody okay on these things? All right. All right, so that was the power rule. So you spent like 3 days developing that on the computer. Okay, you guys do this problem here. So the first thing that you should do is, yeah, Leila? Nice, and that would be? Okay, good. Okay, you guys do that. Remember, you're trying to find the derivative of this. Hang on, Leila, let me get this up here. Okay, so Leila, you are telling me that you want to rewrite this as? X to the 1/3. And so this guy would become?
The very end should be 1 over.
Well, not the very end. Give me the intermediate step.
1/3 times x to the negative 2/3.
Okay, nice. And then?
And then that would be 1 over 3 times the cube root of x squared.
Fantastic. Good job, girl. Okay, Leila, you need to go up there and do this on the board and explain. Developing a lot of these rules. Let me show you where they are. They are right there. And you can bring this stuff in. Now, you know, yeah, you should have that. It's been on my website since day one. Okay, and I've asked you to print that out. Now, you will see that this doesn't quite look like the rules that I gave you in class, but if you want to rewrite this in the format that I have in my class, I'm okay with it. Okay? I'll just make some connections in a minute. Let's just do the next rule and then see what happens, and try and make a connection with what's up there, okay? So the next rule is the constant multiple rule. The constant multiple rule. Okay? So take this down and then I'll show you how it is formulated in that, in that formula sheet there, okay? It's not quite the same, so if you want to rewrite that, I'm okay with it, okay? Give me a minute, I'll get there in a minute. Alright, so the reason why it's called a constant multiple rule is that this A here is a constant. So it's like this guy here. So for the example that we have, A is equal to, right, -5. And if you apply the rule, what it says is that you leave the -5 alone. And what's n equal to? 2, you bring that down and reduce it by 1, which gives you that. Right? Is everybody okay on that? Right? Has everybody got that? Okay, in that case, you guys do this. What's the first? Too many threes again? Too many threes again, Heather? Or too many twos? Do you want me to change it so there aren't all those threes there and make 1 a 5? Would that help you? Yeah? What? You want to make it a 1? Okay, so what's the first step? What's the first step? Henry? Like you got separated? Oh, that hurt. That hurt. What do you mean? What do you mean separated? Yeah, you could do that. That'd be your constant multiple, but then what? When you see a radical sign there, what's the first thing you need to do? Make it into an exponent. Okay, make it into an exponent. So what you really want to do on this one here is to rewrite this as -2/3 x to the -2/3, because see how it's downstairs? Is everybody with me on that? Okay, now you guys need to finish this then. Okay, sum and difference rules. Okay, sum and difference rules. They look pretty complicated. Oh, you know what? I want to go back to, just give me a minute, and I want to go back to what I told you about the formula sheet and show you the constant multiple rule. Is this the one? Yeah. So here's the all the formulas you've got. Okay. The constant multiple rule is right there. It's not quite in the same form that I showed you. So if you want to rewrite this, go ahead and do it. Okay. Go ahead and do it. It's all right with me. Okay. All right. So this is the formula sheet that you're allowed to bring into every quiz, test, and so on. Okay. Including the summary sheet. Okay. All right, going on to the addition subtraction rule or sum difference rule. Okay, so there is a rule and there is an example there. Okay, so let's go review that. All right, so this is what you want to differentiate. Okay, that's the function you want to differentiate. If you differentiate this, you get that. Is everybody okay with that? Do I need to explain that? Is everybody okay on that? All right. And this plus sign remains a plus sign. That's why it's called a sum and difference rule. If it's a sum, it stays as a sum. Okay? And then the 3x, I want to make sure you guys understand that. This guy, when you differentiate that, you get a 3. Is everybody okay with that? No. What's the derivative of x? 1. 3 times 1. Okay? Is everybody right? Cindy, did you get that? Yeah? Did you get that? Okay, is everybody okay on this? Sum and difference rule? Yeah? Right. Okay, you guys do this then. So the answer you should have really, Taddy, you should have been a little bit more thorough and actually written down f prime of x equals, okay, negative 6x squared plus 2x plus 1. Okay, that's the answer there. All right? Right, next rule. Yeah. And this is the last set of rules. This is the sine cosine rules, okay? So the derivative of sine is cosine. The derivative of cosine is negative sine. Okay. And again, like I tell you, these formulas are already there on the formula sheet, so you don't have to fret about memorizing them. But you got to know the formula sheet well enough that you know where to look, because there are a ton of formulas on there. Okay. If you don't know where to look, it's not going to be very helpful. Yeah. Felix, no. I think he passed out because he had to donate blood, so decided not to. Nope. I'm telling you, man, he passed out because he knew he had to donate blood. So, yeah. Oh, I'm going to tell him you said that. All right. You guys got this down? Yeah? Okay, let's go use this then. Okay, how about if you just do this one, okay?